This question is for Year 11 methods, question number 10 from exercise 2E. Now, in this question, we're given that a line, y equals 2x plus 3, intersects the y-axis at point A. So if I draw a quick graph, we know that this line has a positive gradient and it has a y-intercept of 3. So it looks something like this. And this is point A, and it intersects at 0, 3. That is a y-intercept. So it's already in gradient intercept form. The points B and C on this line such that AB equals BC. Now, B and C could be somewhere here or somewhere there. We don't know. So I'm not going to draw it yet. What other information we're given is that the line through B perpendicular to AC. We know AC is on this line somewhere. So point B perpendicular to AC means I have a point B on this line. And we want a line that goes through B but perpendicular to AC. We know AC is also on this line, so perpendicular to AC means perpendicular to this line. And we know that the gradient of this line is, since we have the equation original line, 2x plus 3, we can read off the gradient as being 2. So we can say that m1 equals 2. So for a line perpendicular to this line, we need to find a relationship. What is the gradient m2 equal to? We can work that out because we know that m1 times m2 equals -1 for lines that are perpendicular to each other. So let's plug that in. So we know that the gradient of the original line is 2, and we get m2 equals to -1/2. So the gradient of the perpendicular line is equal to -1/2. Now, we're also given a piece of information about the perpendicular line. It says the line through B perpendicular to AC, which is the line I've just drawn, passes through the point D, -1, 6. So on this line, we have a point D, and it passes through -1, 6. Since we have a gradient and a point, we can find the equation of the line. So it says find the equation of the line BD. So BD means this line. We're trying to find the equation of this line. So it's the same line. So how do I do that? Let's use the formula. Remember y minus y1 equals m x minus x1. We plug in the point D onto it to get the equation of the line. So our y1 is 6. Our m is -1/2, because we just worked that out, and our x value is -1. So -1 is +1. Rearranging this to make y a subject, we get -1/2 x minus 1/2 plus x. So y equals -1/2 x plus 5.5, and that's your equation of the line BD. For part B, we're trying to find the coordinates of B, because they've only given us the point D on the perpendicular line. The point B happens to be where the original line and the perpendicular line intersect. So very simply, we're trying to solve for the equation for when they intersect. So our equation 1 would be original line, 2x plus 3, that's equation 1, and we want to find where it intersects this line, the line we just worked out, the perpendicular line. So y equals -1/2 x plus 5.5, that's equation 2. Since we have y equals that and y equals that, we can make, to find intersect, we can make both of them equal. So therefore, I can make 2x plus 3 equal to -1/2 x plus 5.5. I'll write that better. So we have, I've moved the x's onto the left hand side, so we have 2.5x, and I moved the numbers onto the right hand side, equals 2.5. So dividing both sides by 2.5, we get x equals 1. To get the corresponding y coordinate of the intersect, we plug it back into either one of the equations. I'll plug it back into equation 1, and we get y equals 2, 1 plus 3. So that is 5. So y equals 5. So they intersect at 1, 5. So point B is 1, 5. So point B has the coordinates 1, 5. Now for part C, it's a bit more tricky. We need to look at our original graph. So we know that the coordinates of, so we want to find the coordinates of C. We know that B and C lie on this line such that AB equals BC. So we know from our line, like this, we know that's point 3 and that's point A. We know that point B is 1, 5. So B would be somewhere here, and it's 1, 5. So the coordinates of that is 1, 5. And A, the coordinates of A is 0, 3, because it's a y-intercept. So we know that the distance, the points BC line this line, such that AB equals BC. So AB equals BC. So these, we don't know what the coordinates of C are, but we know that the distance between AB and BC are the same, because the line AB equals BC. So the distance has to be the same. Now, so essentially B would be the midpoint of this line. I'll draw this line properly. It's meant to be a line, not a curve. But you get the idea. We've got a situation where we have B as the midpoint. So we can use the midpoint formula to work out what C is. We know that, so we have point A, 0, 3, point B, 1, 5, and then point C. We'll call it x1, y1. We know that B is the midpoint, so, and we know the midpoint formula is such that M is the average of the x values, so average of x1 and 0 divided by 2 for the x coordinates, and for the y coordinates, and that equals 1, because we already know what the midpoint is. We just don't know what the point C is. And the y coordinate, the average of the y coordinate, so 3 plus y1 on 2 equals 5. So solving that, we know that x1 plus 0 on 2 equals 1. So therefore x1 must equal 2. And for the 3 plus y1 on 2 equals 5. So 3 plus y1 equals 10. So therefore y1 equals 7. So your coordinates of C are, so the coordinates of C must be 2 and 7. And that's how you solve it. So the key part to solving part C is reading the question and getting the coordinates of B, which we found in part B, which is 1, 5, because that was key to working out where C was. Because I could have had a situation where C could have been, B could have been here, C could have been here. So I didn't know whether it was below, on this side of the line or on this side of the line. It happened to be on this side of the line. And that's how you solve